Okay, so for this part of the further technique of differentiation, we are focusing on logarithm, but specifically, we are not focusing on LG. We are focusing on natural log, LN. If you still remember, LN is the one with base E. So we are focusing on the natural log. So if they usually they won't ask you to differentiate LG, but if you are really asked to differentiate LG, right, it will involve some amount of change of base. So anyway, now we will not focus on LG first. We'll be focusing on LN. Okay, so because this is a form of logarithm, there will be some amount of logarithm rules. So this type of differentiation is kind of in between trigo differentiation and exponential differentiation. It will be a bit more difficult than exponential, but easier than trigo. But if you are not very good with log, so sometimes you might find yourself having a bit of mind block. Okay, so differentiating log ln, okay, like I say, right, we focus on ln. So it depends on whether is it ln x or not. If it's just ln x, differentiate ln x, it will just become a 1 over x. Okay, so this one is like kind of disappear the ln. So when you differentiate ln x, right, you realize that you don't have any more ln. It became a fraction. So what happened when it is ln ax plus b? So when it is a ln ax plus b, you will disappear the ln and it becomes something like this. But you do need to differentiate this as a separate function. So you need to differentiate that as a separate function, and that's how you get the a as the numerator. So the first layer is you disappear the ln to become 1 over something. Then you differentiate that function there. So in general, if it's a ln fx, so what do I mean by ln fx? Sometimes they can give you a ln trigo. They can give you a trigo inside a logarithm. So whatever is it, you disappear first. You disappear the ln, becomes 1 over fx. And then you differentiate the fx as a separate function. So that's the general one that we will be doing. Okay, and then the log rule that we will be using are usually the one that says log AB. Do you remember this part? If it's a log of a product, it will become log plus log. So that is the first rule. Another one that you learn is a log of a fraction. If it's a log of a fraction, it will become a log minus log. Okay, this one is the one that is bring down power. Okay, hopefully most of you can remember. So remember logarithm, we can bring down the power. So these are the 3 main logarithm rule that we'll be using. Okay, so we'll do the basic first. So you disappear the ln first. How you disappear the ln? It became a 1 over 2x plus 1. Then you differentiate this. So slowly you can find yourself like doing mental. It's quite easy to mental this. Then as for this one, disappear the ln first. And then you differentiate the function. So this is a linear function. Quite easy to differentiate. You will get a 5 if you differentiate that function. So same thing here. Disappear the function. Differentiate. Sorry, just now it's like differentiate. disappear the ln function and you differentiate this. So it becomes 6x. So eventually you'll find that at the end of a simple differentiation like this, right? You started off with some log, but after the differentiation, the ln kind of disappear. Okay, so for this kind of basic one. Okay, then maybe you can take a look. Okay, when do we use logarithm? Okay, and what happens when you don't use a logarithm? Okay, so I will show you this one. If let's say you fail to see the logarithm, if you fail to see the logarithm, you got to disappear the function first. Okay, then you got to differentiate this portion. So differentiating this portion is actually a product rule. Okay, so if you didn't recognize that it's actually a logarithm, you can still do something like this. But if let's say you recognize that this is log of a product, you apply the logarithm, it will become log plus log. So if you recognize that you can do a log plus log, then you differentiate separately. You differentiate separately. And you will end up having a cotangent x. So you can make it into like this, or some people make it same denominator. So the answer look very different, but both are the correct answer. Okay, so you can simplify the cosine over sine, or you can make it same denominator. So that's why for this kind of differentiation, some students, they find that how come my answer always look different from the given answer? It's due to different way of simplifying. Okay. So the next one, okay, so the next one is actually another logarithm. It's logarithm of a fraction. Okay, so I show you the logarithm of a fraction first. So I will get a log minus log. So if I get a log minus log, I differentiate them separately. So that will be my answer. So you have a choice. Sometimes they might need you to simplify into a single fraction. So if that is the case, you just make same denominator. So if you make same denominator, you realize you got a ninth fraction. So what will happen if, let's say, you forgot the logarithm rule? So if you forgot the logarithm rule, you do by your usual method, you will disappear the ln first. And you got to differentiate the function with a quotient rule. So it actually become very complicated because if you take a look here, the first part is 1 divided by a fraction. So that will have given you a fraction if you flip over. And if you go and do the quotient rule, okay, I do a quick one. If you do a quotient rule, hang on. Huh? So if you do a quotient rule, this is what you will be getting. Okay, you can do it your own. I'm just doing it mentally like this. So in fact, right, minus 3x, I will get this. I can still cancel. I still end up as the same answer. So some of you might prefer this way. You can try. It's okay. So do something that you're comfortable with. Okay, so if let's say you never recognize that you can use a log, you can do a direct formula. So it's just that you must recognize that differentiating the fraction involves a quotient rule. Okay, so for this one, okay, this one, right, I will apply the bring down power for logarithm. Okay, let me show you the bring down power first. So I will bring down the power. So I'm not differentiating it. So after I bring down the power, I will differentiate. Okay, get rid of the ln function. And then you differentiate this part. So all in all, you'll be getting this as your dy dx. It looks quite short. Okay, so again, I'm going to show you what happened if, let's say, you forgot to bring down power. It's still achievable. So a lot of time, a lot of students really forgot that they can use a logarithm. So they will get rid of the function. They get rid of the ln. And then they differentiate this part. So this part will involve the chain rule. Bring down power, minus power, differentiate inside. So this part will involve the chain rule. So it's still quite manageable. You'll get a minus 3, 4 minus x squared, and then the denominator is 4 minus x with a power 3. So if you simplify the bracket, you will get the same answer, exactly the same answer. Okay, so everything will work. It's just whether you remember to use log or not. So again, right, not all the questions you can be using logarithm. Sometimes you will still need your product rule and the quotient rule because the log can be combined with exponential. Okay, so you will see some of this in the next example.